how Google conducts more, better, faster experiments. So Google has published a paper where they discuss and they say we need to run more experiments, but some of the experiments are overlapping. For example, we want to run 1,000 experiments instead of 10, but when we run them, they then step on the foot of each other. There are more chances that someone will change something, for example, the background color to be the same as the font color, and then the UX will break. How then can you scale your experimentation system to support multiple experiments while still not breaking the UX and being scalable and also being an easy platform and not super complex? So let's see if this blog post will explain this. So this is a post by Shengyu Chen, and so let's go with it. Google initially published a paper around 2010 on setting up the experimentation infrastructure to support running faster, better, and more experiments. Here's the link. The following is a cursory attempt at understanding Google's approach. Overview. Google conducts experiments to modify user interfaces and change ML algorithms that affect ranking or content selection. To support this goal, Google needs 1. Sufficient infrastructure to support. 2. A wide range of tools to support the usage of infrastructure. 3. Great educational processes to help users make better use of these assets. Defining an experiment. Representative segment of the population. So an experiment, is a representative segment of the population. A change that's interested to be tested. Example, visible changes such as UR or non-visible changes such as changes to the underlying ML algorithm in ranking output. 3. A split on the representative segment of the population. Test set and control set. 4. Response to the change that's of interest, that is the objective click-through rate, conversion rate, sales, and other types of business metrics. So they describe here in general what is experiment. We take the population, we split it, and then we measure it. So far makes sense. At Google, experiments are run to 1. Test out new product features, explore the space around existing features. Current challenges as of 2010. At Google. Keeping up with the rate of innovation is difficult. Testing as many ideas as possible is necessary but not supported. Challenges related to experiment infrastructure. 1. Single layer of experiment structure. Every query, when we say here query, we mean an actual query. When you do a search at Google, so this is a query, right? So every query is in at most one experiment. It was only in at most one experiment. This is easy to use and flexible, but insufficiently scalable. So there's always this balance between how easy the system is and how flexible. 2. Multifactorial experiment structure. Every parameter, factor, can be experimented on independently. Each experimental value for a parameter overlaps with every other experiment value for all other parameters. So this is important. Multifactorial means we have multiple parameters that we want to change. So how would you be sure of the right combination or how they work? You need to get all the permutations in a full multifactorial. This is called a full multifactorial. Just check all the permutations. You get traffic, you take one permutation of 10 parameters and you send it to it. Okay, so let's read this. 2. Multifactorial experiment structure. Every parameter factor can be experimented on independently. Each experimental value for a parameter overlaps with every other experimental value for all of the other parameters. Each experiment query will be in n experiments simultaneously. and n is the number of parameters. Even this structure is impractical since at Google there are thousands of parameters to be experimented on, and not every factorial combo should be testing. Yeah, sometimes combinations of parameters is not interesting. Pink text on pink background, and even breaking the UX. So basically what pink text, here the example is pink text on pink background, for example, yeah. So what they're saying is that we don't really need all the combination of the parameters. Not only don't we do not need them, we do not want them, because one of the combination is breaking the UX. Pink text on pink background. So this is good for us because this is both good and bad. It's bad because we need to know about this, but it's good because it's removing some combination of factors. So the goal of a better experiment infrastructure is one, more scalability, more and better, faster, more, better and faster. One, more scalability to run more experiments simultaneously and flexibility to run different configuration sizes while maintaining the statistical significance. Two, better. Invalid experiments shouldn't be run at all. Valid but bad experiments should be caught quickly and disabled. Standardized metrics should be made available faster. Quick and easy to set up an experiment. The proposed solution: partition the parameters into subsets. So always in computers, the way to solve problems is to break the problem. So we partition the parameters into subsets. Every subset contains parameters that cannot be varied independently of each other. So the background and the foreground would be in a specific subset, right? Because we cannot change them independently. We cannot change both to black. It wouldn't. The screen would be black, fully black. We won't see any text. So in each layer, in each subset, we place parameters that cannot be varied independently. Parameters that, when we change one, we want to change the other, probably. Two, every subset is associated with a layer that contains experiments. Okay, so we imagine here a couple of layers, and experiment one goes to layer. Each subset is associated with a layer that contains, okay, so in a layer we have multiple experiments according to this. Each experiment's query would be in n experiments, and n is the number of layers. So we get a query. The query could go, each experiment, what does it mean, experiment query? Okay, I estimate, but let's see, that query is in multiple experiments. Yeah. And because the different layers can have parameters that can change independently, then the assumption here is that multiple layers will not affect each other. I'm not sure how can we be sure of this 100%, but this looks like the solution. So in this way, we can have multiple layers here. Imagine here multiple layers, multiple experiments, and we get a query, put it both in this experiment, and this experiment, and this experiment, and this experiment. In this way, we were able to run multiple experiments. Yeah, so far looks good, but the devil is in the details. How do you exactly split to the layers? Okay, 3. Each experiment can only modify parameters associated with its layer. Yeah. And the same parameter cannot be associated, with multiple layers because same parameter is dependent on itself. So we cannot put a parameter that is dependent on itself in multiple layers. We said that each layer have parameters that are dependent not independent one on another. Okay, so each layer holds parameters that are closely related one to another, like foreground color, background color. They are closely related, so they are in the same layer, and we cannot run multiple experiments on them. So we have different experiments on different layers. Okay, so far so good. But we didn't get yet into the details. I'm interested to know how do you split to the left? How do you know which parameters to put in each layer?